Hi everyone, welcome back to our channel. Today we are going to discuss about the properties and theorems of Laplace transform. So these are very much important to solve the problems in Laplace transform. Okay, so first property we are going to discuss today is linearity property. Okay, so first property is linearity property in Laplace transform. Okay, so this is defined as Laplace of f1 of t plus f2 of t plus and so on up to fn of t. If you find the Laplace of this function, then you are going to get f1 of s plus f2 of s and so on up to fn of s. This property is called linear T property, and this is used to transform a finite sum of time functions into frequency domain. Okay, the same function I can write down with the help of a scaled value. So Laplace of a1 into f1 of t plus a2 into f2 of t and so on up to an into f1 of t. Therefore, this we can write down it as a1 into f1 of s plus a2 into f2 of s and so on into an into fn of s. This is how to write down. So this property of linear addition of time function is called, and it is written in Laplace transform. It's nothing but f1 of s. So here these functions are in time domain, but here the functions are in frequency domain. There's the main importance you need to understand while you are transforming. Okay, so second property or the second theorem we are going to understand is nothing but scaling theorem. Okay, so what is the importance of this theorem? Let's try to understand. So whenever a k is called a scalar and a function f of t is there, when Laplace of this function is performed, then you are going to get k into f of s. This k is called scalar value or scaling factor. So Laplace of k into f of t, where k is called multiplier or k is called scalar. When it is multiplied k times, then the f of s is also k into f of s. Okay, so this is the second theorem and second property of our Laplace. Third property of the Laplace is differentiation by time domain. So differentiation in time domain. This is also called, so we are going to find the do the differentiation in time domain. This also we are going to call in one more name called as a real differentiation. Okay, so that is Laplace of d by dt of f of t is equal to, so this I can write on it as capital letter S in frequency domain f of s minus f of 0 minus, where this represents the initial condition of the inductor or the capacitor, where this is called the initial condition of inductor or capacitor, and this is called just before switching operation. Okay, so this is what we call the differentiation. So how to write down in a standard format also we'll discuss. Okay, so that is Laplace of d to the power n divided by d t to the power n into a function f of t. We are going to write down it as s power n into f of s minus s to the power n minus 1 into f of 0 minus minus s to the power n minus 2 into f dash of 0 and so on f to the power n minus 1 into 0 minus. This is what the general formula. Let's try to do it for n is equal to 2, which is Laplace of d square divided by dt square into f of t, and consider here n is equal to t. So whenever n is equal to t, which is called s square f of s minus s to the power 1 into f of 0 minus s to the power 0, which is nothing but 1 into f dash of 0. This is how to find out for a second order system. This property is very much useful in transforming a differential time domain function into an frequency domain or the algebraic equation. This is called real differentiation. Similarly, we are going to understand about real integration transformation. So the next property is real integration property, or how to understand. So that is Laplace of integral 0 to t f of t dt, we can write down as f of s divided by s. So this is the real integration. Differentiation means it gets multiplied into s into f of s minus initial content. It's nothing but integration. It will divide by frequency domain s. So fifth property is nothing but differentiation by s. Okay. So differentiation by s. The meaning here is d by ds. So what is this differentiation? When you are going to get d by ds, that you are going to get when you perform Laplace of a time domain function into same another function f of t. Here it is called time multiplication, or two functions are there in terms of time function. Laplace of t into f of t, we can write down it as minus d by ds, where d by ds is called as differentiation by s, and multiply this function with f of s, then you are going to get the differentiation of d by ds. It is nothing but multiplication with time. So a function is multiplied with time into f of t, then you are going to get minus ds into f of s. Okay, so this is the differentiation by time. And sixth property we are going to have, which is nothing but called as a shifting theorem. Okay, what this shifting theorem teaches? The shifting theorem is defined as whenever a function is there. So for example, let's try to take a step function. It is delayed by a time of t second. How much time it is delayed? So this is delayed by time of t second, and this delayed I can write down it as, generally this function I have to write down it as f of t, but it is delayed by a time of t, then I am writing it as f of t minus tau, and it is delayed by a time of t second. Therefore, the function I can write down it as Laplace of f of t minus tau is equal to, so since it is an f of t, Laplace of f of t is how much? F of s. So Laplace of e to the power minus at, you can write down directly in exponential e to the power minus tau s into f of s. This theorem is called shifting theorem. Why it is called shifting theorem means it is shifted by a time interval of capital letter t. Therefore, this theorem is called shifting theorem or a delayed function. So this theorem is called shifting theorem, or a delayed function of magnitude of capital letter T, or this is also called real shift, or this is also called real translation real translation theorem or shifting theorem. So hope you are able to understand all this. Let's try to revise the things. Laplace of f of t plus f2 of t is equal to f1 of s plus f2 of s. So Laplace of scaling, Laplace of k into f of t is k into f of s. Laplace of differentiation is s into f of s minus initial condition. Laplace of integration is f of s by s. Differentiation, when you are going to get differentiation of ds, is that is when the time is multiplied. This is one time function, this is another time function. Two time functions are there, it is multiplied with the time of t, then you can write down it as minus ds of f of s. Okay, so next one is shifting theorem. It's nothing but Laplace of f of t minus tau is equal to e to the power minus ds into f of s. This is all about the different properties of Laplace transformation. Okay, so let's try to discuss about the remaining two properties in the upcoming session, which are nothing but the initial value theorem as well as the final value theorem. So first, let's try to discuss about the initial value theorem and final value theorem. So hope you are able to understand the basics of the theorems and the properties of the theorems. The next theorem what we are going to discuss is nothing but initial value theorem. Okay, so next theorem is initial value theorem as well as final value theorem. These are very much important for us to discuss. So hope you are able to understand all the basic properties. If you feel the content is useful, please like the video and share with your friends. If you have any doubts, let me know in the comment section. I can answer your doubts. And if you're watching the channel for the first time, subscribe to my channel with the name KB Tulsiram. Thank you for watching. We'll meet in the another video. Yours obediently, Ram.